Hello friends. In last video we saw that methods inside a generic class can make use of a class type parameter and automatically generic relative to the type parameter. Also we saw that it is possible to declare a generic method that uses one or more type parameters of its own. In this video, we want to see that it is possible to create a generic method that is enclosed with a non-generic class. Before starting, if you have not subscribed to my channel yet, please subscribe to my channel and also push like button to encourage me making more videos. Thank you. Let's see an example. In this example, we declare a non-generic class called generic method test and a static generic method which is called contain. The contain method determines if an object is a member of an array or not. It can be used with any type of object and array as long as the array contains objects that are compatible with the type of the object being sought. As you can see, the type parameters are declared before the return type of the method. Also note that T extends comparable. Comparable is an interface declared in java.lang package. A class that implements comparable defines objects that can be ordered. So requiring an upper bound of comparable ensures that contain method can be used only with objects that are capable of being compared. Comparable is generic, and its type parameter specifies the type of objects that it compares. Also, you can see that the type V is upper bounded by T. It means V must either be the same as type T or a subclass of T. This relationship enforces that contain method can be called only with arguments that are compatible with each other. Contain method is static, so it can be called independently of any object. And also it means generic methods can be either static or non-static. There is no restriction in this regard. Now notice how contain method is called in main method, without the need to specify type arguments. This is because the types of the arguments are automatically recognized and the types of T and V are adjusted accordingly. The type of the first argument is a string, which causes a string to be substituted for T. The base type of the second argument is also a string, which makes a string a substitute for V. In the second call, double types are used and the types of T and V are replaced by double. Although type inference will be sufficient for most generic method calls, you can explicitly specify the type argument if needed. For example, here is how the first call to contain looks when the type arguments are specified. Here we will get error. The reason is that the type parameter v is bounded by t in the extends clause in v's declaration. This means that v must be either type t or a subclass of t. In this case, the first argument is a type of a string, making t into a string, but the second argument is a type of double, which is not a subclass of a string. This causes a compile time type mismatch error. This ability to enforce type safety is one of the most important advantages of generic methods in Java.